All right, let's try another one of these. Example 6.1.2, evaluate the integral of x cubed over square root of 16 minus x squared dx. This is going to be a squared. Always take a to be positive. So I get a equals 4. And so I'm going to apply this technique here. So I'm told to take x equals a sine theta, so 4 sine theta. That means dx will be 4 cos theta d theta. Here you can learn it by heart, but really it's just differentiating the one above. You know how to do this. And then the square root. The first time we did this in chapter 5, we actually used a trig identity to get it, but now we can use the method, or in fact the triangle. Right, so from this we get that sine of theta, let me write it here, is x on 4. And so I'm going to put x as opposite, 4 as hypotenuse, and then the last side has the right square root. And if you check what cosine theta is, it's going to be adjacent. So it's adjacent over hypotenuse, so over 4. And so you can see the square root from the triangle is 4 cosine theta. So you could get it from the trig identity, you could get it from the method, you can just learn it, or you could get it from the triangle. All right, so every time you have an inverse trig integral like this, you start by writing all of this, then you rewrite the integral. All right, so I have x cubed over the square root dx. So x cubed, I'm going to plug that into it. So I have 4 sine theta cubed. The square root is 4 cosine theta, so 4 cos theta here, and then the dx, that's this part. Don't forget the dx, please. Sometimes it turns the integral into something impossible. All right, so the cosine cancel, the 4 as well. So I end up with 4 cubed, which is 64 sine cube theta. All right, so like I said at the end of the last video, at this point you get an integral of trig functions. You have to remember the recipes that we taught you for odd, even, number of 10, odd numbers, stuff like that. That's where it comes to play. Here I have an odd number of sines. And so what should I do? Do you guys remember? Substitution with the other one. So that's going to take away one of the sines. So I'm going to get, let's put the 64 up front, sine cube theta minus 1 over sine theta du. I end up minus 64 sine squared du. Oh, forgot, dropped my angle. And so that's 1 minus cos squared. And so we get minus 64, 1 minus u squared du. And we're ready to integrate. The integral of 1 is usually x, but that's because I usually have x as my variable. Here I have u, so the integral of 1 du is just u. And then u cubed over 3 plus c. And now I slowly go back. First thing is I replace u by cosine. So I'm going to get minus 64 cos theta minus cosine cube theta over 3. And then I want to go back to x because the original question was in terms of x. So I need to rewrite cosine in terms of x. I'm going to use this. Cosine is adjacent over hypotenuse. I have it here as well. So here I'm going to get minus 64. We said square root of 16 minus x squared. That's adjacent. Hypotenuse is 4. Yeah, adjacent over hypotenuse. All right, and then we do the same thing. Cubed and divided. Let me put the 1/3 in front. Otherwise, I'll have fractions over fractions, and that can lead to mistakes.